Hi and welcome. This time around we're back to the Cloud Ray laser project. I've been using this a bunch. It actually was living over there on top of that tool cabinet in the empty space, and yes, off to the side there is the CO2 laser. I still have not unboxed it because I have nowhere to put it, and I really don't, it's really not enough different from the fiber laser with some deficiencies compared to the fiber laser that I really need it. So its wavelength is 10,000 nanometers or 10 micrometers. This guy is 1 micrometer, the fiber laser. So I'm going to stick with the fiber laser because it's more versatile, can cut metal. The CO2 laser can't because 10 micron wavelength light reflects off of most metals, so it won't cut them. This guy, however, had a problem when I first got it, that when it tries to auto home, find the 0 point, which is the top of the column here, it would just crash. And I work with Cloud Ray Laser. They were really good, by the way. Their customer support was excellent. And they determined that it was a bad switch, but it could also be a broken wire. So I'm going to investigate that some more. To be honest, waiting for this thing to go all the way to the top of the column to find 0 every time you power up is a little, time consuming. I don't really need that feature. What I did is in the software, I just set my 0 point and then tell it that this is my 0 point and go from there. And that works great for me. So I'm going to fix this, but I don't know that I'm going to take it off manual. I'm also going to replace the lens, which means I'm going to have to calibrate it. Let me go down here. So underneath the galvo head here is a lens. This lens does a 4x4 area, which you can see marked out on the aluminum plate there. I have another lens that'll do up to 8x8, which I'm going to need in the future. On top of that, I have the rotary attachment, which is over here, sitting on top of the CO2 laser for lack of storage space. And I'm going to add the hardware for the rotary indexer as well. So that's what this project is this time around. I don't know if I'm going to be able to get to the calibration of this lens when I swap it out, because you have to recalibrate when you swap lenses. You can store it in a file so you won't have to do it a second time. But I might be doing that. I don't know. We'll see how much I have time for this time around. So we got to open the laser case here, which is always kind of fun, because we've got to add a stepper driver in there and set that up for the rotary encoder, because it doesn't come pre-installed, even though I ordered the thing with the rotary attachment option, but they didn't do it in the factory. So that's actually good, because then I'll get to see what's inside and whatnot. I always like that. The first step in the instructions to checking the limit switch is to remove this piece here. You're supposed to have the column all the way at the bottom, and then this piece, you remove 2 screws here, is supposed to come off. So let's try that. So we've removed these 2 screws. This piece is actually a really tight fit, which is nice. I like to see nice fitting things. And under here, what you can't see is the limit switch, which it incidentally, there is this little ball bearing extension. This is a copy of a micro switch. That micro switch is actually a brand, kind of like Kleenex is to tissue paper. And this part right here just fell off down the column. So I guess I found my culprit, that the micro switch is indeed broken. It actually broke plastic. So one of the conductors is missing. That's really an interesting failure. We're going to remove the existing micro switch, held in by a single screw. Yeah, the switch is completely broken. I don't know if you can see that, but this end right here, the entire end's broken off. And every time I push it, more pieces fall. Really nice with Cloud Ray. When they gave me the replacement micro switch, they also gave me 2 pieces of heat shrink. That's very thorough. I appreciate that. Here is another micro switch style switch, similar. This one is Cherry. If you're a gamer, you've heard of Cherry before. Their switches are very popular for gamers. Here's an original micro switch, and very solid and positive click on this guy. And here's a Matsushita Japanese brand, very positive click also. The one they gave, though, is not an inexpensive Chinese brand unless it's a clone. It's actually an Omron, and it's also very positive. So we just must have had bad luck to cause it to break, because this is actually a decent brand. I've used Omron stuff before. So we'll put this one back in. Originally I was going to put the Matsushita in there, but you know, I think the Omron's going to be plenty good. This one's very positive. This one's reasonably positive. It's got a much lighter push, and maybe they want that. The contact force is a lot less on this guy. To make it easier to get to the wires, I'm going to take the handle off this thing. It's actually a keyed knob. There's a little key stock right there. And I'm going to pop the top up because I can't get to all the wires and back as much as I'd like. I could do it with this little sticking out, but apparently there's a junction back in here that they want you to attach to, or maybe it's so you can stuff the wires back in, but it's actually kind of hard to do that with the top on, so I'm going to take it off for ease. And it's actually pretty easy and convenient to get to, so that shouldn't be too hard. There we go. I like that. Now we have access to the wires directly. When I want to stuff the remaining wire back in there, that'll be easy to do. So the first step would just be to cut this off right next to the switch. That wire wasn't tinned very well, so I will do that. I'm going to pre-tin the wires here because they were not tinned adequately, or at all really. Since I have tons of extra room in the column, I put the heat shrink on there. I'm just going to try and butt joint these. I originally was just going to run the wires to the connectors, but there's tons of room in the column to store the extra wire. So it'll just be easier this way, and it'll make it easier if I have to swap this in the future. Alrighty, should be good to go there. We'll just shrink the heat shrink on there, put the micro switch back, and hopefully we'll be good to go. I'm not quite sure which direction I should orient this switch either. I should have paid it was oriented, I think, like this. I guess, yeah, that would catch there's a roller that rides on this rail here, going up and down. There's actually a ball bearing roller down there. That must have been what was making contact with it, so they did put it over there. And if this wasn't set right, I guess you could, before it stops, you could just break the roller, break the whole end of the switch off, which is what happened. Interesting. Alrighty, we're good to go there. Interesting. This Omron is obviously a English unit device because the holes, this is an M2.5 screw, and it just is a little too big to fit through there, which means they probably drilled it out the first time. And if they did that, that would weaken it slightly. So that might explain a lot why a high quality switch like this. They didn't say I was going to have to drill this out, but clearly I'm going to. Trying not to get in the way of the camera here. A little challenging. Wow. I generally think a second screw would have been a little more secure than just the one. So holding the connector here, they didn't carry the wire colors all the way through, which is really annoying. I am currently on yellow, and the center pin, which I figured would be common, which is actually white. These are red and black wires. But that's carrying through, so I'm going to guess that's correct since I don't know what their actual pinout is. That's kind of crazy. I guess if I opened the main case, I could find out what the pinout should be, but I would have carried the wire colors through because that would make sense to me. The connector they use is a Switchcraft clone. I've always called them Switchcraft because I hated even the actual brand that made these. This is a clone one, so it's even a little clunkier. Not a fan. So I want to see if this switch is going to engage when it hits the top. So I kind of got to put this back together, which might make it a little hard for you to see. I'll see if I can get a better angle for you. And actually, if I keep these loose, it'll make putting that other piece back on a little bit easier when I get there. So I'm going to leave that a little loose. They pre-grease this to hold the key in the keyway. So this is a cast zinc centerpiece here, cast into the plastic. With the keyway, makes it plenty strong for this application. And the fit is surprisingly good. No complaints about quality. You can hear that. That repeatability will determine how accurate this homing is. So that's another reason I'm not a huge fan of it, because this is not a precision operation. If that does not repeat, well, let's say that repeats plus or minus 10 thousandths, then that's as accurate as you're going to be, plus or minus 10 thousandths on your position, which to me is not ideal. I think it's a challenging thing to make a very accurate switch that repeats so that when you reach a certain point, usually they do that with, you know, crossing a light beam, something of that nature for super accuracy. That's why there's optical scales. They can obviously do it magnetically too, but I don't think that's quite as easy to pull off as the optical is. Although you do have diffraction around the edges, so that causes some issues with the optical method too, which it's not perfect. My guess is in the factory, when they put this micro switch in, when they tightened it, it rotated too much, and when this thing came up, it just snapped the end off the switch, because it's a reasonably strong stepper motor there. All right, part one done. Next step, we're going to modify this guy. We need to put in the stepper motor driver, which is right here. They sent it separately. We also have to configure it. I think they want it set to 12,800 pulses per revolution, which is up here. It could go as much as 25,000. When you go with quarter stepping and half stepping, what ends up happening is the amount of torque the motor can produce gets reduced. Although on a rotary device, there's probably not a ton of torque. You probably could get away with the higher number, but for now I'm going to set it for what they wanted, which is 12,800, which would be switch 5, 6, 7, and 8, on, off, off, on. So I'm setting them right there. It tells you which way is on. There's a little arrow pointing down. So 5 is off, 6 is on, 7 is on, 8 is off. 12,008. Oops, did I get those exactly backwards? I did, didn't I? All right, that's better. How about on, off, off, on? 12,800, on, off, off, on. And then microstep peak current setting is currently set 1, 2, 3 on, which would be none of those. I don't know. Correction, these are set 1, 2, 3 on. 1, 2, 3 on is 1 amp peak current, which is the absolute minimum. I guess I need to find out what this stepper intends to be driven with. It'd be nice if they'd set that in the factory, and maybe they did, but then this would have been wrong, because their own video shows 12,800 and it was set to all offs, which would have been 25,000. First step, I removed the 6 screws, 3 on each side here. Hopefully this will come right off. It does. Very nice. I like the fact that you can get into it from the top. So just 6 screws on the top. You don't have to tilt this over or anything. So there's the JPT laser power supply. And at least on this end, there's no connectorization. It just comes straight out, which connectorization is dangerous, because any bit of dirt or impurity on the lens or on the fiber to laser connection would cause a potential where heat would build up and destroy the item. So that's why they do that. It's much safer if you just go fusion spliced all the way in. The laser itself is actually a section of fiber that is ytterbium doped. So on this side is just power supplies. Well, I'm kind of psyched out here because the rotary package came with this, but I think they're assuming you didn't have one. But when I follow the connector on the back over here, so there's a wire running from the connector which would go to the stepper motor. I follow this wire right here, and sure enough, it goes to the bottom stepper. It's already connected. So I guess I have a spare stepper motor. I didn't need to take this apart, but it was fun to do anyway. So that's kind of cool. I'm glad that it's pre-wired. The wiring is excellent, and they put labels on every wire, which you don't see all that often. I got to give them huge kudos for this, because that's very impressive. A lot of the Chinese stuff, the wires just go where they go, and you'd have to figure it out. This one, they all have little tags on. If I pull this Phoenix connector off here, see, the wires have all have labels. These two that go to the bottom connector don't have labels, but the wires that they mate to do. A+. Thumbs up to Cloud Ray on this. So both drivers here, I checked to see where they were set. The current settings are different for the two of them. So the top one is all off, and that's the column, the Z column stepper. So that's this column stepper here, which probably needs to be higher current. Let's see. All off is full current, 5 amps. The bottom one is for the rotary, and that one's set for 2 amps. Oh, look at that, different model than these two. These are R57Gs. Very interesting. So that worked, but it says it's out of negative range. So when I change the parameters, it's almost like zeros in the middle. I'm not quite sure what it thinks it's doing. I'm kind of thinking that maybe what I have to do is I have to put this in the middle. Before it was going down and crashing, so I said, I guess you need to go positive. So I changed the software option to positive, and it actually worked. It came up and stopped just fine, but it says it's out of range. So I'm going to put this in the middle, turn off the software, which will cause EasyCAD to crash out, because if it doesn't see the controller, it crashes. So I'm going to start it up with this in the middle, and then see if it'll run up and stop. Maybe it's considering where it is now 0. I don't know. Okay. So positive direction, I'm going to tell it to find home. And now it doesn't go as far, so hopefully that will work. It does stop. There we go. But axis out of negative range. I don't know what that is. I'm going to ask CloudRay about it. Personally, again, I don't care. I can set home manually, and I guess I'm just going to have to do that because this isn't working. I'm going to call setting the height automatically a total fail. Next up, we want to swap the lens out with something with a wider field of view. This one should be good for about 8 inches. I got to figure out where in the software you set this to. It's not at all obvious just looking at it. One thing that's very important is that you keep all of this very clean, because if it gets dirty, then you get the risk of having the laser hit the dirt, creating a hot spot and damaging the lens. So we're going to be very careful with this. So to remove, all you do is unscrew the old lens. And thread in the new one. Oh, huh. Look at that. The threads are wrong on this. I can't screw this one in, this outer piece here, unless that comes off, and you have to swap that with it. Oh, it looks like you do. There's an adapter piece that you have to take off. So this guy has this adapter piece that lets it thread on. Ah, there we go. They didn't tell me that in the instructions. I was going, that's not mating up at all. Okay. So once you get the threads on, reverse directions so that you make sure that you're not cross-threading. And there we go. Old lens off, new lens on. That was not obvious. They don't explain that very well. Note that the focal length is written on the side of the lens. In this case, focal length 290 millimeters. Then we have to set up and calibrate this lens. All right, so we're going to find the focal length for the new lens. And the way you do that is you disconnect the Z-axis servo, remove the Z-axis power feed, and you tell it to mark a rectangle continuously. When replacing a lens, the first thing you do is you open up EasyCAD and you need to change a couple settings. First up, under the general settings, we go to general and we look to make sure that we're in the mode we want to be in, which is millimeters as opposed to inches, because this is a Chinese unit, so everything's already in millimeters, so I might as well stay there. Next up, you go to workspace, and the new lens has a coverage of 200 by 200. Now I've already changed it here, but you need to make the width and height 200 by 200 to match the lens or whatever your lens is. And then the X and Y settings, I make 0, 0 dead center in this square. So in order to do that, I've got to make X and Y bottom left minus 100 and minus 100, which is what I've set here. That makes the top right plus 100 plus 100. The center is 0, 0. You can see on the markers there the measurements, and the bottom becomes minus 100, as you can see there. Next up, we need to draw a box so that we have something to see while we're setting our height for focus. And we go up and we select the rectangle we just drew, and we unclick the lockbox, which keeps the aspect ratio the same way as you just drew it. Then we set it to 50 by 50 because that's an easy measurement to make. And we might as well make it centered as well. As we hit C for center, that's a shortcut, or you can put 0 in the X and Y there. And then we could just mark it. But before we do that, let's change some settings here. We're going to change the default parameters from true to false. That'll let us make changes to the power and whatnot. So we're going to leave the frequency and the speed alone, but we're going to take the power and reduce it. And we might as well reduce it down to something like 20. I've even done as little as 5 watts on mine. Mine's a 100-watt laser, so this is in percent, so 20% is 20 watts on mine. Then we can come over and hit mark, and it'll do one loop and mark it one time around. But and that actually works well if you're lowering the column, hitting mark, lower the column, hit mark, and move the part over. But that is not ideal if you have your hands busy like mine were, so I put it on continuous. So if you go over here and click continuous, then the whole time, once you hit mark, it'll continuously mark around that rectangle, and you can adjust your height and see when it's making a sound. And what I do is I just move the part around while I'm adjusting height. Like this. And you adjust until it's not cutting. Bring it into cutting. And then it goes away again. And that's how you find your 0 point. I'm thinking that's about it right there. Hard to tell. You're going by sound, but it's actually etching into the material each time. Now the other thing you'll notice is, see these 2 dots? That's these lasers over here. And you notice how they're not converged on this? You need to aim those both at that point, so when it's in focus, those 2 dots point at that dot, because that means that helps you find focus without using a little height measuring tool. So my head's probably in the way. There's 2 little screws you'll loosen to make this adjustable. One thing I find that helps is to pop on some welding glasses, because that laser is so bright, it reduces the diameter of it to the very brightest part in the center, which lets me really line that up. And now that I've got that centered, then I can close this off so I don't have to risk accidentally getting the other laser in the face. And we just have to adjust this guy right here to also be centered. First I need to give it a little snug, because it's so loose now that it's too easy to move. So first I'll get it fairly close here. Fairly close. Pop on the welding goggles. This is oxyacetylene, and it looks like they're right on top of each other. So I think we're good. Next up, since I couldn't get the software to generate a correction file to work, I'm going to do manual adjustments, and I will set use correction file to false. And I'll use internal correct to true. I would mark it. Once you've marked that square on here, I know that's kind of hard to see, catching a lot of reflection, you take your calipers and you measure this box. So it should be, I have it set for 50 by 50, so it's 50 tall in the Y direction, 50 in the X direction as well. Whatever that correction is, let's say it measures 62 and 62, just for example. Then I would go into the software into the X and Y scaling percentage, divide 62 by 50, and that value I would multiply by 100, so call it 1.21 times 100 is 121, and then I'd enter that value in the scale factor under the X value. And I do the same for Y. In this case, both of my boxes were larger than they should have been. Next, to adjust pillow factor, which is how out of straight the lines are. You take a ruler, you print a bigger box, and you take a ruler, and if the box bows in, then the pillow factor needs to be increased. If the box curves out on the largest size box you can do, then you want to subtract the pillow factor. So in my case, it curved out on the X-axis and curved up, or curved in on the Y-axis. And as a result, I would change these values under the pillow factor, reprint the box, and see how close it is to straight. After a lot of printing, changing, printing, changing, I was able to dial it in so that my boxes would print not only to size that I put in the software, but also square. There are also adjustments for parallelism and trapezoidalism. Parallelism is if the top line is not parallel to the bottom line or the left line is not parallel to the right line. Trapezoidalism is if two side lines tilt in, say, and the top and bottom are parallel or vice versa. And you can correct for those as well. And when you're done with these corrections, you should be able to get pretty close to exactly what you envision when you set the software to print something specifically and accurately. And that's about it for this go around. I now have a lens that instead of a 4-inch area can now laser engrave on an 8-inch area. And you can barely see the box here. That wasn't quite full range on it. Matter of fact, I marked fairly close to full range on the table here. I also moved the whole unit so that it was centered over my previous box. Thanks for watching. Hope you find it useful. Hope to see you next time.